Thanks everybody who joined my talk. It looks like that you are interested in Kubernetes or logging or large-scale setups in Kubernetes. So my talk may be interested to you. And I'll talk about large-scale logging in Kubernetes, how to efficiently collect these logs, how to efficiently store these logs, and how to efficiently query these logs. Let me introduce myself. I'm a software engineer, and I'm fond of programming in Go, and I'm fond of writing optimized programs in Go, fast programs in Go. Probably if you program in Go, you know my packages such as fast HTTP, quick template, and so on. And during the last few years, I started my own project. It's VictoriaMetrics. It's open source time series database and monitoring solution. It's like Prometheus. And recently, I also started another project, which is Victoria Logs. It's observability solution for logs, database for logs. And I'll cover this database later in the second part of the talk. Let's refresh our knowledge about Kubernetes. Probably somebody doesn't know what is how Kubernetes works. What is this? So let's refresh knowledge. The Kubernetes is a cluster which runs on top of some hardware, some nodes, hardware nodes, and it consists of control plane which manages all these nodes. Every node has some amounts of CPU and memory and network, and control plane manages all these nodes. Every node may contain arbitrary number of pods, and every node contains kubelet. It's a service from Kubernetes which manages all these pods which run on every node, and every pod may contain multiple containers. Containers are basically just Unix processes with some limits on memory and CPU, and these Linux processes run Docker images usually. And containers which run on the same pod usually share the same persistent volumes, so they can access and communicate through these shared persistent volumes. That's basic knowledge about Kubernetes. And what about logs? What is logs? Let's refresh our knowledge about logs. Logs may have different types. The first type is info logs, like when your service runs and you need to provide some information about state changes in this service. Like, so when service starts, you can log the information that the service had been started at the given time. There are debug logs when you need to debug some issues with the service. Then you enable debug logs, which are more verbose than info logs, and they help debugging your service. There are error logs. These logs are usually used for informing about some unexpected conditions when some query cannot be executed. There are fatal logs when your service cannot process further because of some fatal errors such as out of memory crash. There are access logs which are used for logging some web service access for different pages from some users, from some IPs. There are audit logs which are used for logging some information about some changes performed by users in the system. And these audit logs help investigating some problems in the future related to users' interaction and user actions in your system. And there are traces. This is also some kind of logs which allow you tracing the execution path of your request to the system or to system which consists of multiple microservices. As you can see, all the log types have some common structure. All these log types have a timestamp. That's one common structure of the logs, the timestamp. Also, log types usually have some level, this info, debug, error, fatal, and so on. And also, different logs have some fields, common fields, which are highlighted in bold in these log types. And these common fields can be stored in separate fields in logs, and in this case, logs are converted from unstructured to structured. So if you store these bold words into separate fields, then you get structured logs. How Kubernetes generates logs? First of all, Kubernetes components can generate logs on itself, such as control plane components, such as node services components, which run on every node. And also, most of the logs are generated by user containers, which are deployed into Kubernetes by users. And the vast majority of logs are generated by microservices in Kubernetes. How these logs are generated? What are the destinations for logs generated by Kubernetes? The most common destination of logs is std_out and std_er. This means that applications which run in Kubernetes containers just put their logs into std_out and std_er. They also can put their logs into custom files, and also they can push the generated logs directly to some external database for logs. And the common approach in Kubernetes for logs generation is to generate these logs into std_er, std_out. That's the Kubernetes native approach for generating logs. And Kubernetes components generate logs into std_out and std_er. How these logs can be investigated? Kubernetes automatically collects logs from std_out, std_er from every running container. It puts these logs into separate, distinct files on local Kubernetes nodes where this container runs. And every such log file is limited in size with 10 megabytes by default. All the logs are automatically dropped. So Kubernetes automatically rotates logs for you. And also logs for stopped containers are eventually dropped by Kubernetes. What does this mean? And all these generated logs can be inspected and analyzed with kubectl command, kubectl logs command. That's example how to investigate logs for some container which runs on some pod. The features of kubectl logs are: the first feature is that kubectl logs scales great to millions of containers because for every container it just stores logs into local files on this local node. This means that the number of log files is limited on every node. And if you add more nodes to your Kubernetes cluster, then this means that you increase the capacity and scalability for this logging solution in Kubernetes. That's why it scales to millions of containers if you have Kubernetes cluster with thousands, tens of thousands of nodes, for instance. kubectl logs allows following logs for running containers. It supports tail-f functionality. That's great for debugging of currently running containers. And kubectl logs integrates with traditional Unix command line tools such as grep, head, tail, and so on. You can write kubectl logs f, so it follows logs for some container and then pipe these logs to different command line tools from Unix in order to further analyze these logs. But kubectl logs has some issues. The first issue is that it is limited by default to 10 megabytes of logs per each running container, as I already said before. Of course, you can increase this default limit, but in this case, you should know about this, and it may increase disk space usage on your Kubernetes nodes. And logs for stopped containers are eventually dropped. This means that you cannot investigate logs for already stopped containers because they are lost. Also, kubectl logs doesn't provide the ability to quickly search for some trace ID, for instance, for some string, Unix string across a large volume of logs. For instance, find of logs with some given trace ID when you want to investigate all the logs related to some request across multiple microservices. Also, kubectl logs doesn't provide tools for log analytics. For instance, you cannot find containers which generate the most of the logs, or the most of the logs which contain some particular string. Which requirements should be satisfied for large-scale logging solution for Kubernetes? The first requirement is this solution should forward logs from all the containers in Kubernetes to a centralized database for logs. And there are multiple good solutions for this requirement. Almost every popular log shipper, open source log shipper, such as FileBit, FluentBit, Loki shipper, and so on, satisfies this requirement. They can be installed as on every Kubernetes node and collect all the logs from all the pods, all the containers running on every Kubernetes node, and push them to the configured centralized database for logs. So this problem is solved. And the next problem is requirements for database for logs. It should be able to efficiently accept and store huge amounts of logs. Obviously, if you run millions of containers and these containers may generate a lot of logs, then you should have the system which can handle these huge loads of logs. The system also should provide fast full text search over large amounts of logs, such as terabytes or even petabytes. And also the system should provide fast analytics over large amounts of logs. Because that's why we collect logs. The first reason why we collect logs is to be able to debug these logs later. So you need fast full stack search and fast analytics over large amounts of logs. Which databases do exist for Kubernetes logs? You can use traditional databases such as MySQL, Postgres, and so on, and store these logs from Kubernetes to these databases. And it even works okay for small volumes of logs, but it stops working good for large volumes of logs because of scalability issues for traditional databases. They usually need a lot of disk space, a lot of disk I/O, memory, and CPU, because they are not optimized for this, for storing logs and analyzing logs. And also, traditional databases have not so good usability for typical logging tasks for analyzing logs. They usually provide SQL, and SQL is a very powerful query language, but it is not optimized for typical tasks for logs. There are better languages for logs. What about analytical databases? Have you heard about ClickHouse database? No? That's great open source analytical database. It is optimized for storing a lot of data in it and performing fast queries over this data. It works when compared to traditional databases such as MySQL and Postgres. Then ClickHouse can perform queries on the same hardware up to 100 times, even 1,000 times faster on the same hardware than traditional databases. So it scales great for large log volumes, but it has issues because it is not trivial to configure it properly. And it needs custom tools for log ingestion and log queries, because it provides the same SQL, custom SQL dialect, and you need to use this custom SQL dialect for log ingestion and log querying. And it also this custom SQL dialect is optimized for analytical tasks, and log tasks may be not so good correlated with analytical tasks. That's why ClickHouse is a good solution, but it has some issues. What about document indexing databases such as Elasticsearch and OpenSearch? These databases provide fast search and analytics over large volumes of logs because they are optimized for such tasks. But they have issues. And the first issue which you stumble when you run collect logs into Elasticsearch and OpenSearch on large scale is large memory requirements. So you need a ton of RAM for large log volumes. There are specialized databases for logs. The first open source database, which you probably know, is Grafana Loki. It provides good compression for logs. It's optimized for storing logs, so it compresses logs much better than Elasticsearch, for instance, or traditional databases. Not talking about ClickHouse, because ClickHouse also compresses logs good. But Loki has issue. The issue is that it doesn't provide fast full text search. It is not optimized for fast search over logs because the developers of Loki decided that it is okay to just scan all the terabytes of logs when you perform some query over these logs. And Loki has another issue, is it's hard to configure and operate properly. If you ever tried running Loki, then you obviously know about this issue. And what about VictoriaMetrics? That's a log database for logs developed by me, by my company. It is trivial to set up and operate because I personally work on this to make a trivial setup and operate all the products which we develop. And it also uses low disk space, small disk space. When we run benchmarks against Elasticsearch, store the same logs into Elasticsearch and VictoriaLogs. Then the final result is that VictoriaLogs uses up to 15 times less disk space compared to Elasticsearch for the same logs. Also, VictoriaLogs uses very low amounts of RAM memory compared to Elasticsearch, up to 30 times less memory for the same amounts of logs, for the same queries, for the same workload. And VictoriaLogs, contrary to Grafana Loki, it provides fast full-text search over logs like Elasticsearch. Also, VictoriaLogs provides a custom query language for typical log analysis tasks, and we'll look at this query language a bit later. What is VictoriaLogs? It is open source database for logs written in Go, because I like Go, and I writing fast programs in Go. It is easy to stop and operate. It contains a single executable, small executable, relatively small executable, around 10 megabytes. And it doesn't need any complex configuration. It runs optimally with default configuration. And it supports popular log shipping protocols, such as syslog, Elasticsearch, Loki, Vector, FileBit, FlanBit, Logstash, and so on. You can read more about this by this link. And it provides query language optimized for logs, LogSQL. Also, this binary, VictoriaLogs binary, has built-in web UI. For if you prefer web UI instead of command line interface, then you can use this web UI for querying logs. And VictoriaLogs integrates great with traditional Unix command line tools such as lesshead and so on. We'll look at this later in action. I'll show you how it runs in real time. Let's look at this VictoriaLogs query language. It is very easy to learn and use. You'll see this in a few moments later. It is optimized for typical log analytical tasks. It works good with structured and unstructured logs. It supports data extraction and transformation at query time. This is good for processing and analyzing unstructured logs, and supports powerful analytics. And let's look at some examples and run these examples in real time. How do you think how the query for selecting all the logs looks in LogSQL? It's just star. So let's try this example here in command line. So I have a small bash script wrapper, vim logs query, which sends the query to HTTP endpoint and returns the result. Let's run this simple query. And it runs this query against the sandbox at VictoriaMetrics.com. This sandbox collects all the logs at our sandbox Kubernetes clusters for the last year. And this cluster contains around 2 terabytes of logs right now. So let's look how it selects all the logs. I forgot putting this. Oh, I think that terabytes of it's not a good idea to select all the terabytes of logs. So what can we do? We can pipe this to less, and then investigate these logs at slow pace. So you can see every log line is just JSON with some fields, time, stream ID, stream message, and so on. You can format these fields with JQ in order to better read them. It's better looks like right now. So what's the point? The point is that right now I just run this select all logs from 2 terabytes of logs command right now, and as you see, it executes almost instantly, and the VictoriaMetrics service doesn't crash at that time because it selects all the logs on demand when the client reads these logs from the response. And if clients stop reading these logs from response, then the server stops searching and processing these logs. That's how it works. And also, if you stop executing, cancel executing the query, then VictoriaLogs server instantly discovers that the client closes the connection and instantly stops processing this query and frees up all the resources. That's why you can freely select billions of logs with a simple command. Let's look at other more complex queries. How to count the number of logs for the last hour. That's how query looks like. Let's try executing it. Oh, what I did right now, I execute this query across all the logs, not for logs for the last hour. I forgot putting this filter on time. And you can see that the number of logs in the database is 1.7 billion, and the query has been executed in 5.8 seconds. Not so bad. And let's count the number of logs for the last hour. So the query is executed much faster, and the number of logs for the last hour is 176,000. So this slide has incorrect query. Okay, how about selecting all the logs with some words, such as error word? That's typical task when you investigate logs. Let's execute this query. Just type error word in the query. So you see that there are a lot of different information, and you can see that every log message, it's not visible. Let's make it more visible. So you can see that every log message which has underscore message name contains the error word here. No, it is not case sensitive. If you need case sensitivity, then there are solutions. The first solution is to enumerate these different cases which you expect to find, for instance, like this one. Or you can, this query works fast. Or if you can use regular expressions with case-insensitive regular expressions, they are not so fast as this query type, but it works. If you don't know every possible case, then you can use regular expression. As I remember, like this one. So if you type tilde before the query, then this means that you're going to put the regular expression. And as I know, in order to find case-insensitive matching in regular expressions, you need to type this one. Let's look. Yes, I think that it works like expected. Yeah. Okay. Let's go further. How about selecting all the logs with their word over last 5 minutes? Just type filter on time for the last 5 minutes and the word which you want to search. That's how it works, and we can count the number of logs. We can count the number of logs for the last 5 minutes with error word by two approaches. The first approach is to use traditional Unix command line tools such as WC. You can just pipe all the selected logs into WC, and it will show you the number of logs, 3,500 logs. And another approach is to calculate this number of logs at query time with the query here. So you can see the number is almost the same. It differs because this system runs and collects logs at real time. So let's look at this how to select logs with the different words over the last 5 minutes. I guess you already know, because I already showed you how to select logs with different cases. Just use OR, and you can use parentheses in order to make this query more visible, the intention of the query more visible. Because if you don't put this parentheses, then the query will be executed as find the logs for the last 5 minutes with the error word, or any logs with the warning word without the filter on time. Okay, let's run this query and see what it shows. Oh. Mm-hmm. So I typed the fields filter on the query in order to limit the number of fields which the query returns. It just returns only message field, and you can see there are a lot of different messages matching this filter. These messages contain either error word or warning word. And let's filter out some logs with this file to process request a string, because it looks like that these logs are too noisy, and we don't want to see these logs. Let's ignore them. Then we just type this phrase in quotes and put this exclamation mark in front of this phrase. And in this way, we just filter out these unneeded logs. Let's run it again and see that this phrase doesn't appear in these logs. Okay. That's how this query runs. So this is more complicated query. As you know, Kubernetes contains containers which generate logs, and every container generates its own log stream. And VictoriaMetrics knows about this, or VictoriaLogs knows about these log streams, and you can query particular log streams with particular names and so on. So let's query log streams for containers with the name FluentBit GKE. Let's try it. JQ. So here we have logs with different log fields, and one of these log fields is Kubernetes container name. Yeah, you can see that this Kubernetes container name Grafana, GK metadata server, and so on. So let's select all the logs for some Kubernetes container for Grafana, for instance. How to do this? Just type this Kubernetes container name field name and type colon, and after the colon type the filter for this particular column, Grafana, for instance. So now you get only logs for this particular Grafana container. Kubernetes container name. Okay. There is a container with which contains Grafana word inside the container name field, like Grafana SC dashboard at the top. We can type the query which strictly matches only Grafana. Just put equal sign in front of Grafana, and let's run it again. And now you can see that the Kubernetes container name only contains Grafana word. That's how it works. Okay. How about selecting all the logs which contain some IP addresses over the last 5 minutes? IP address can be expressed as a regular expression like this one, and in this way we can select all the logs which contain this, which match this regular expression, and this means that they contain some IP address. Let's run it. Bum, bum, bum. So we put this tilde in front of the filter, which means that we are going to type some regular expression, and let's type this regular expression. I hope that I typed it correctly. Let's look at it. No, something is wrong. Here should be square brackets. Yes. So you can see that VictoriaLogs returns you only messages with some IP addresses. How about extracting these IP addresses? Okay, that's another query. How about extracting these IP addresses and counting the number of most frequently seen IP addresses? This can be done with extract regexp function. Just type this query, this regexp again. And put this regexp here again. Pum, pum, pum. No, something is wrong. What is wrong? No. It is okay, but no. Oh, it's hard. Let's try, just execute this query from which I already prepared here. What does it do? it searches for logs which contains this remote addr equal substring, and then extracts IP address from this substring with the extract function, and then calculates statistics by the extracted IP address. It counts the number of matching rows per each IP address, and then sorts this statistics by rows in descending order, and leaves only the first top 10 rows. That's how it works. Let's execute it and see what it returns. Oh, yeah, it works, and it returns some IP addresses and some statistics, the number of matching logs with the given IP addresses over these lines. Okay, let's go further. More advanced functions. For instance, select top 5 containers which generate the most of logs with the error word for the last 5 minutes. This query will return you this information. Let's try executing this query. Yeah, it works. The flying bit GKE container generates the most of error logs according to the stats. Okay, let's go further. Oh, that's a monster query. What it does, it selects the top 5 container names which generate the biggest error rate over the last hour. This means that it calculates the total number of rows per each container, the total number of rows per each container with the error word, and then divides the number of rows with errors by the total number of rows, and filters the error rate. It should be bigger than 0 because we are not interested in containers which do not generate any logs, and also it filters out logs which generate only errors with this filter less than 1. Then we sort the statistics by error rate in descending order and leave only top 5 entries. Let's look at the query result. Yeah. So fluent bit GKA container is not good. It generates most of errors. 99% of all the logs from this container contain error word. And other containers generate slightly less number of errors. That's how it works. Okay, we have left a few minutes before the end of my talk. Yeah, 15 minutes. So I recommend you trying VictoriaLogs in Kubernetes and reading LogSQL docs, because LogSQL contains many different other things which are useful for typical log analysis tasks, which are not covered in my slides. So I recommend you reading these docs. And let's look at the production case numbers for VictoriaLogs. These numbers are collected from this running system, which was used for executing queries during this talk. As you can see, this Kubernetes staging cluster was generated 1.7 billion of logs during the last 10 months. Let's execute this query again and verify that the number of logs is correct. Yeah, 1.7 billion logs here. The disk space usage, all this 1.7 billion of logs occupy 33 gigabytes of disk space right now. And the uncompressed size of these logs is more than 2 terabytes. This means that the compression rate for these logs, for typical Kubernetes installation logs, is more than 60 times. By the way, these names in braces, VL storage rows, VL data size bytes, VL uncompressed data size bytes are metric names which are exposed by VictoriaLogs and which are collected by VictoriaMetrics, and you can look at this information at these metrics, how they change over time when you run VictoriaLogs in your environment. Memory usage, it uses only 200 megabytes of memory on average during data ingestion. Of course, it can use more memory during heavy queries, but in steady state, it uses 200 megabytes. And CPU usage, it uses only 5% of single CPU core right now for collecting all this stream of logs. As for performance, this VictoriaLogs instance runs on in a container, Kubernetes container with 4 CPU cores limit and 14 gigabytes of memory limit. And this VictoriaLogs instance can return you the last 100 logs with the error word in 50 milliseconds. It can count the number of logs with the error word for the last day in 0.6 seconds, and it finds around 1 million of logs in this case. It can count the number of logs, total number of logs over the last 100 days in the same 0.6 milliseconds, and it finds almost 500 million of logs. It can find the top 5 applications, Kubernetes containers which generate the most of logs over the last 100 days in slightly more than 1 second. It can count the number of logs with some very rarely seen strings, such as foobar, across all the billion logs in 4 seconds. It finds around 300 entries across this number of logs. So it's quite performant. And I think that we have some time for questions. Yeah. Yep.
So first question, if I let's say
have a... It's switched on. Yeah.
So first question, if I let's say have a Kubernetes cluster with several namespaces, but I want my customers only to see the logs from their namespaces, is there some kind of role-based access control? So I can limit the visibility of logs to, let's say, particular namespaces. And the second question would be, is there a way to integrate dashboards? Or can I use the output from VictoriaMetrics or VictoriaLogs in a dashboard?
Regarding the fine-grained access, RBAC access, VictoriaLogs doesn't provide any such role-based access right now. Probably this may be good feature request in the future, but not right now. I think the most straightforward solution for this access restriction is to use different instances for different namespaces of VictoriaLogs and protect every such instance with some authorizing proxy in front of it. As for second question regarding dashboards, VictoriaLogs has a Grafana plugin for Grafana, so you can install this plugin and build dashboards in Grafana with queries for VictoriaLogs. And obviously, you can use any other data sources in Grafana. You can query VictoriaMetrics, Prometheus, and other databases on the same dashboard. Yep.
Thanks for the talk. I have also two questions. One, is there a data retention strategy where, for example, logs like older than a year are deleted automatically? And second, well, not all of us have the luck to work on Docker Kubernetes stuff. For example, I have a huge monolith application that nevertheless writes like a dozen different log files from different components. Is there a way to ingest them and separate by the source file?
I forgot your first question. Could you repeat?
The first one was about data retention.
Regarding retention. VictoriaLogs provides two approaches for data retention. The first approach is to it accepts command line flag, which sets the number of days for the retention. And VictoriaLogs automatically drops all the logs when they go out of the retention. That's the first approach. And the second approach, you can set the maximum disk space usage for VictoriaLogs logs. And when this limit is reached, then VictoriaLogs drops all the oldest logs. That's how retention works right now. And this retention is global. You cannot configure it fine-grained on different types of logs. And the second question is?
It was about monolithic application with multiple log files.
If monolithic application generates multiple log files, then you can use the same log shippers, such as FileBit, configure them to collect logs from any number of log files located in different directories and push these logs to VictoriaLogs.
And are they separated similar to the Kubernetes containers?
By default, VictoriaLogs has Kubernetes not operator, a Helm chart in just Kubernetes logs. That's linked for Kubernetes Helm chart, and this Helm chart by default installs this FileBit on every Kubernetes node and sets up this FileBit to collect logs generated by every container and send these logs to VictoriaLogs. But it doesn't support this case you mentioned with monolithic application, and you need to write this configuration, figure out this configuration on yourself in this case. So that's all. Okay. Thank you for attending my talk again. And try VictoriaLogs if you run Kubernetes, large-scale Kubernetes.